like to do when we're dealing with how to do a sample problem here for centripetal force is I remember back when I was a kid and we used to go to the roller skating rink, we used to play a game called Crack the Whip. And maybe you do something similar. I know I'm not the only one that did this, but the idea is that all the people go out on their roller skates or ice skates, wherever it may be. We all hold hands in a big line, and then what we do is we skate around in a big circle. The idea being the person in the middle sits still while the person on the outside has to skate around in the outside circle. What made it fun is, the person on the outside starts to get this big force acting on them, and they get thrown off eventually like we've cracked the whip. So let's go around and take a look at how we would do this problem. So let's just say, for saying sakes here, that the people that go around in this circle, they travel at what we call 3 RPMs around. Now what that means is the people skating would make one revolution, they would make 3 revolutions every minute. So RPM stands for revolutions per minute, and if we were moving around at 3 RPM, that would mean everybody would get back to their starting spot 3 times in 1 minute. The other thing I want to do here is, let's say the mass of each skater. So the mass of each skater is, let's just simplify it a little bit here, and we'll just say they are 50 kilograms because we were kids when we were doing this. So the question I want to take a look at is, how much force would be needed to keep, say, a person who's right around here, 3 meters out from the center, how much force would be needed to keep them traveling in a circle? So a little bit later they're going to be over here, and this is the direction they would be moving. Because they have mass, they have inertia, which means they want to keep moving in a straight line, but there has to be some force pulling them back to the middle. Okay, and we call that centripetal force. So my question is, what force is needed to pull that person back into the middle? So let's go ahead and see if we can calculate that out. To figure out centripetal force, it's mass times velocity squared divided by r. So let's identify the variables that we have. Well, in the problem, I told you that we have the object's mass and we have the object's radius as listed right here. But if we look, we don't actually have the object's velocity. I'm going to put that in a different color so we don't get so confused. All right, so let's say right there, we don't know what that person's velocity is. But with a little bit of work, we can figure this out. Velocity is equal to an object's distance divided by time. Now, what shape are these people traveling in? They're traveling in a circle. So what distance do they have to travel? Well, this little person here, she's going to go around the circle, right? And they're going to, what do we call that outside thing of the circle? It's called the circumference, and circumference is calculated as 2 pi r. If you don't believe me, that's what it is. So here's the distance the person's going to travel divided by the amount of time. Now there's something we need to remember, and that's the fact that this person's going to go around that circle 3 times every minute. So they're not just going to go around the circle once, they're going to go around the circle 3 times. So they're going to do 3 circumferences in 1 minute because we gave you the speed of 3 RPM. So let's go ahead and calculate out what the person's velocity would be, plugging in our numbers. We put the 3 times around the circle, 2 pi, and then the radius of the circle was 3. And then this is revolutions per minute. So how many seconds are there in 1 minute? There's 60. And if you calculate this out, we'll be able to get the person's speed. That object, that first little skater there, has a velocity of 94 meters per second. And so what we can do now is we can plug that in up above. Okay, so if we take a look here, the person had a mass of 50 kilograms. They're moving at a speed of 0.94 meters per second. We square that and we divide it by the radius of 3, and it takes 14.7 newtons of force to hold that person in the center of the circle. So not too bad. But this game was called Crack the Whip because the person on the outside ended up getting flung off. So let's take a look at what's going on now with the person that's located out here. All right, so say the person that's red. So they're going to move around, same deal, but remember they're moving around a bigger, they have to travel a bigger distance. So in order for this to happen, they have to be moving a lot faster. All right, so let's go ahead and calculate out what their centripetal force would be. Let's put that in a different color. Let's make it green. What force is needed to keep them into the center of the circle? Doing the math over here would be the same deal as what we had before. And the fact that we know the mass, we know the radius, but we don't know the velocity. So our first step is going to be figuring out how fast that person goes. So let's calculate their velocity now. They're still going around the same circle 3 times. The distance they travel in each circle would be the circumference, and so that's calculated as 2 pi r. And I'm just going to get rid of the r right now and let's put it in there. Here's the thing to notice though. This time, this person isn't just a distance of 3 away for the radius. They're 3 plus another 3, meaning that they are a total distance of 6 meters from the center of the circle. All right. And then that's the distance they're going to travel. And once again, this is 3 RPMs or revolutions per minute. So they're going to do that 3 times every 60 seconds. Let's go through and calculate it out. All right, so if we take a look there, we can see that by moving the person out, the first person was only this far away. The new person is now twice the distance. What do we see there about the velocities? The velocities have increased, but it's more than just that. The velocity is actually increased by double. By having twice the radius, we end up traveling twice the circumference in the same amount of time, and so the velocity of this person has increased quite a bit. Let's use that number to see what effect that has on centripetal force. All right, when I ran that through my calculator, I got a force of 29.4 newtons. Now, what does that mean for us? That means that skater number 2, all right, our red skater out here, so maybe I'll get red as my highlighter. So skater number 2 here, because they are further away from the center, they end up moving faster each second. And so what that does is it makes the centripetal force a lot more. Now, I know what you're thinking at first. You can look here and you say, okay, well, radius is there, so if I increase the radius, that would decrease the centripetal force. But what we got to balance this against is the fact that because they are further out from a radius, they're traveling a further distance each second, so they're going this far, as opposed to the first person who was only going this far. And so because they're going a further distance in the same amount of time, they end up increasing their velocity a lot more. And what makes the velocity have a bigger impact on the centripetal force? It's the fact that it's squared right there. So yes, increasing the radius does decrease the centripetal force, but if you're moving at the same angular velocity, which means how fast you're rotating, which we are in this case because everybody's playing crack the whip, the person on the outside is going to feel twice the amount of force throwing them off as opposed to the person on the inside. This shouldn't be too shocking. We can run through a couple examples here to see what goes on. I'll switch the colors. So here's centripetal force. Force centripetal equals m times v squared over r. All right. Now what I suggest we do is let's take a look at what happens if we use 2 times the radius as opposed to just the normal radius. So what happens if we double our radius? What would change? So let's go ahead and put it into our formula. All right, when we put it in there, what we end up noticing is, remember, if you got twice the radius, you're going to go twice their circumference, because circumference, once again, is 2 pi r. And since what we're trying to do is to figure out speed, it's circumference divided by time for the velocity. If you end up doubling the distance, you're going to end up doubling your speed. So that's why I put in the 2v. But if we pull these things out here, if we pull the numbers out, what we get is something that looks like this. So we factor out the 2 in front, but it's a 2 squared, and we put that over the 2r that we had at the bottom. And what you end up getting is 2 squared over 2, or as a lot of people like to call that, is really just 4 over 2. And 4 over 2 is the same as saying 2 times as much. So you end up getting twice the centripetal force by doubling the radius. Let's take a look at what would happen if we did 3 times the radius. So let's just repeat this process. I'm just going to copy this right here. Okay, let's repeat this process, and this time, instead of putting in 2's there, let's put in 3's and see what happens. By having 3 times the radius, you'd get 3 times the velocity, but you'd also have 3 times the radius. That would lower the centripetal force. The velocity is squared, making it 9 over 3, and that simplifies down. So by doing 3 times the amount, you're going to have 3 times the centripetal force. All right, so what this means for us is this. Centripetal force, despite the fact that it has radius in the bottom, if you increase the radius, you're also going to increase the centripetal force, because increasing the radius also affects the velocity. And because that velocity is squared, that counteracts anything that you would going on. So when you first initially look at this thing, you might think that it's an inverse relationship, but it actually works out that they're directly proportional. 2 times the radius is going to mean 2 times the force. 3 times the radius would mean 3 times the force. Hopefully that helped out. I'll see you later.